All right, here we go with Unit 2. So Unit 2 is on bonding. There are three types of bonds that we'll discuss: ionic, covalent, and metallic. For the notes, you will want your green notes packet. If you don't have a green notes packet, you can just follow the slides and copy down the information in a notebook. Otherwise, if you have a printer, I put the link on Schoology so you can print them out to follow along on your own. You will also, of course, want your yellow periodic table packet with you and something to write with. So today we're starting with a little bit of ionic and a little bit of covalent, but mostly ionic. So here we go. All right, one thing, I apologize, this is not in your notes, but we're going to add them to your notes. So on page 2 of your notes packet at the bottom is a periodic table. So I want you to take a second and draw that dark zigzag line in on the periodic table and label metals and nonmetals. So metals are to the left of the zigzag line, nonmetals are to the right. So if you need to pause the video, make sure that you draw in and label that distinction. All right, once you have that on the screen, I'm going to have you write the information for ionic and covalent right under your periodic table. So ionic bonds are formed when you have a metal and a nonmetal bonding together. So a metal would be like potassium, a nonmetal would be like chlorine. So if you have potassium chloride, that would form an ionic bond. So ionic is from opposite sides of the periodic table. Covalent is two or more nonmetals. So covalent would be two elements from the right side of the periodic table. Carbon dioxide would be an example, CO2, because carbon and oxygen are both nonmetals. One element that you might want to mark in your periodic table is hydrogen. Hydrogen is located on the left of the periodic table, but hydrogen is not a metal. Hydrogen is a nonmetal. So water, for example, would be a covalent compound. So once you have that information on page 2 of your notes, then you can go ahead and skip back to page 1 so we can start in on ion formation. All right, so this comes from section 7.1 in your textbook. So if you need additional support, reading, pictures, examples, that would be the section to go to. Valence electrons are electrons in the outermost energy level. So if you remember from our first unit, if we write the electron configuration for lithium, we would write 1s2, 2s1. And so lithium only has, oops, my 1 got all messed up. There we go. It's a 1, not an 11. Oh boy, keep making it worse. Okay. So this 1 electron, which is represented here in the atom diagram, that's your 1 valence electron. One important thing to note is that the number of valence electrons for each atom is going to be the same as the group number on the periodic table. Now, here's one thing that I'm going to have you change. This periodic table that you have, the group numbers up top are labeled 1 through 18. Some periodic tables are labeled 1 through 18. However, this middle section, the D block, if you remember with electron configurations, that's when the energy levels started to overlap. So you would go, for example, from 4s2 to 3d10 and then back up to 4p whatever. So these middle D block elements will never be your outermost electrons. So those 10 elements are not counted as valence electrons. So what I would do to help with valence electrons is to renumber those groups up top 1 through 8. So group 1 and 2 would be your S block, and then you'd skip over here, whoops, to boron, which would be 3, 4, 5, 6, 7, 8. So 8 is the maximum number of valence electrons an element can have. The only exception is helium. Helium, since it's in group 1, there are only 2 elements in group 1. So even though helium is a noble gas, helium would only have 2 valence electrons. All right, the octet rule is another definition that you'll see. So octet means 8. So noble gases generally have 8 valence electrons. Noble gases are stable, they're happy, they are non-reactive for the most part. So when forming compounds, atoms basically want to be like a noble gas. They are either going to lose or gain electrons to be stable and happy like a noble gas. So when forming compounds, atoms tend to achieve the electron configuration of a noble gas. Metals will generally lose electrons to become like a noble gas and to obtain the octet rule. Nonmetals will generally gain electrons to be like a noble gas and to obey that octet rule. We'll get more into depth in a few slides with this. All right, electron dot structures are structures and drawings that only show the valence electrons for an atom. So if we had oxygen, for example, let me get my pen. To write the electron dot structure, you would draw the element symbol. So oxygen, the symbol is O. And then if you look on your periodic table, find oxygen. Oxygen is in group 6, which means that oxygen would have 6 valence electrons. So in our drawing, we're going to draw 6 little dots around oxygen. And usually we do the dots kind of one on each side of the, or sorry, 2 on each side of the atom. So there would be our 6 valence electrons for oxygen. All right, we'll do one more example together. Sulfur is right under oxygen, so sulfur is also in group 6 of the periodic table, which means sulfur would also have 6 valence electrons. So then you would draw in those 6 dots for sulfur. And remember, the most number of valence electrons that an element can have is 8. All right, so now take a second, pause the video, try on your own to work through strontium, lithium, potassium, and argon. And then once you're done, unpause the video to double check your work. Make sure you pause the video. Did you pause it yet? Have you paused it? Okay. Here we go. Hopefully you're unpausing and have your answers. So strontium is here in group 2. Whoops. So strontium would have 2 valence electrons. Lithium is here in group 1 of the periodic table. So lithium would just have 1 valence electron. Potassium is also in group 1 of the periodic table. It's in the same group as lithium. So potassium would also have 1 valence electron. Argon is all the way over here. So argon is one of the noble gases. It would have a full outer energy level with 8 valence electrons. So argon is going to have 8 valence electrons. So we'll do 2 on each side of the element symbol, so we have a total of 8. So when you have a total of 8 valence electrons, you can see argon does not want to gain or lose any more electrons. It is full, it is happy, it's stable. That's why it's a noble gas. And so potassium, lithium, strontium, and sulfur are all trying to either gain or lose electrons to look like or to be like a noble gas. All right, here we go, moving on. So we have cations and anions that describe the ions. A cation is a positively charged ion, and cations are formed when an atom loses electrons to obtain a noble gas configuration. So if we look at sodium as a neutral atom and as a positive ion, if you find sodium on the periodic table, sodium has an atomic number of 11, which means it would have 11 protons, which means it would have 11 electrons. So I'm going to write that off to the side here. So sodium would have 11 protons and 11 electrons. So if we wrote the electron configuration for sodium, we would write 1s2, 2s2, 2p6, 3s1. Whoops, we'll scribble that out. 3s1. So in the third energy level, here is sodium's 1 valence electron. So if we drew this, here's our nucleus. Here's energy level 1. In energy level 1, we have 2 electrons. Sorry, my drawing is not going to be very beautiful. In energy level 2, whoops, whoa boy, I better make that one over again, sorry. This is really hard to draw with your mouse. Okay. I feel like by December I'll be really good at this. Okay, maybe not. So in the second energy level, we have 2 electrons in the s sublevel, and then we have 6 electrons in the 2p level. So we're going to have a total of 8 electrons in the second energy level. Get all those electrons drawn. Okay, and then in the third energy level, we just have 1 valence electron. Whoops. So in the third energy level, here is our 1 valence electron. So for sodium to be happy and stable, like a noble gas, and to obey the octet rule, it could either lose this 1 valence electron. So if you took that valence electron away, you would have a full outer energy level. So it could either lose 1 or gain 7 electrons, because it has 1. So if it gained 7 more, it would have a total of 8. So energy-wise, it's much simpler for an element, or takes a lot less energy for an atom to lose 1 electron than to gain 7. So when sodium loses its electron, I'm going to put this off to the side, it still is going to have 11 protons because the protons identifies the element. So if it's sodium, sodium has to have 11 protons. But if it loses an electron, instead of 11 electrons, it is going to have 11. So it's kind of opposite, as you can see. Like if the atom loses an electron, electrons are negative, so it's like you're subtracting a negative. You have more positive charges than negative charges. So if you lose an electron, the atom or the ion would be positive. So if we wrote the electron configuration for an ion, we would have 1s2, 2s2, 2p6. Whoops. 2p6, there we go. So this outermost valence electron is the electron that was transferred. So it's basically transferred to another atom that wanted to gain electrons. So sodium is going to lose an electron. And once sodium loses an electron, now here's our first energy level with those 2 electrons in it. And then here's our second energy level. And in the second energy level, we still have a total of 8 electrons. We have 2 in the s sublevel and 2 in the p sublevel. Whoops. Sorry, my electrons are pretty messy. All right, we need 1 more. There we go. So, and then our third energy level, that's the one that we lost. So our third energy level electron is gone. So now, as Na plus is a positive ion, this atom has a full outer energy level. And it would only have 10 electrons and 11 protons, so that's why it has a positive charge. All right, so now if we move on and look at the negative ions, negatively charged ions are called anions. And an anion is formed when an atom gains electrons to achieve the noble gas configuration. So again, electrons are negative. So if you're gaining electrons, you're gaining more negative charges, making the atom more negative. So if we look at chlorine, on the periodic table, chlorine is over here on the right. It has 17 protons. So I'm going to get my pen back here. So it has 17 protons, which means as a neutral atom, it would also have 17 electrons. So if we wrote the electron configuration for chlorine, we would have 1s2, 2s2, 2p6, 3s2, whoops, that's an S. Whoops, I apologize. That's 3s2. And then 3p5. All right, here we go. We got to draw our atom. So if we have the nucleus here, here is our first energy level with those 2 electrons. And then here is our second energy level. Oh Lord, that's not a good energy level. Oh boy. Okay. Here is our second energy level. In the second energy level, we have electrons on the S and the P, so we're going to have 8 electrons total. Oops. 7, 8. Okay. And then in the third energy level, we have 2 from the S sublevel, so we're going to put 2 here. And then we have 5 in the P sublevel, so we're going to add 5 more. 4, 5. So now we have a total of 7 valence electrons on this outer shell of chlorine. So chlorine can either gain one electron to have a total of 8, or it could lose all 7. So it could lose the 7 that it has or gain 1. So energy-wise, it's a lot easier for chlorine to just gain 1 electron. So when chlorine gains an electron, it's going to start out with 17 protons again because it's chlorine. And then if it gains an electron, now it's going to have a total of 18 electrons. So it's going to have 1 more electron, 1 more negative charge than it does positive charge. So that's why when an atom gains an electron, it's actually getting more negative. So if we write our new electron configuration, we have 1s2, 2s2, 2p6, 3s2. That one looked a little better. And now for 3p, we are going to add 1 more electron on there so it looks like a noble gas. So the ion configuration will end 3p6. So again, we're going to draw our structure. Here's 2 electrons on that first energy level. Here is our second energy level. Whoops. We'll just make that into an electron. Here's 2, 3, 4, 5. All right, and then for our third energy level, we're also going to have 8 electrons because now chlorine has gained a new electron, so it started with only 7, but it's going to gain a new electron to have a total of 8. So we'll have 8 electrons around the outside ring. 1 more. 8. All right, so that's where we get our negative charge for chlorine because it is going to gain an extra electron. All right, so on the periodic table, on page 2 of your notes, I am going to have you add these 2 things. So we'll have you write down the valence electrons. So VE represents valence electrons. And actually, I'm going to have you write it on your yellow periodic table, and that can be a quick, easy reference. So we'll have you write down the valence electrons and the common ionic charge. So group 1 has 1 valence electron, so it could either lose that 1 or gain 7. It would rather lose 1, so if you lose an electron, you're losing a negative charge, so that would have a +1 charge. Group 2 has 2 valence electrons. It could either lose 2 or gain 6. The atom would rather lose 2, so if you lose 2 electrons, then it becomes a +2. Group 3 over here would be +3. Group 4 has 4 valence electrons. They could either lose 4 or gain 4. Group 4 generally don't form ionic compounds, but for now you can just put that it's either plus or minus 4. And we'll kind of talk through those as we get examples. Then we start to progress in the opposite direction. So nitrogen is in group 5. So nitrogen would have 5 valence electrons. So it could either lose 5 or gain 3. Now it's easier to gain 3. So if you are gaining 3 more negative charges, you're going to end up with a -3 charge. Oxygen has 6 valence electrons. It could either lose 6 or gain 2. It's going to gain 2 for a -2 charge. The halogens will gain 1 electron to be like a noble gas. And then, of course, the noble gases don't really form compounds, so we are not going to include a charge for them. So, that was your first section of notes. The other notes, I promise, will not be this long. That has a lot of explanation on the side, but hopefully it helped, and that way you can review the notes if needed, but this will help with the digital notebook slides.